Hi students. In the last class, I have discussed a force acting on a moving charge, right? And in that we have discussed so force is given by Q into V bar cross B bar and angle 0, 180 straight line, 90 circular motion. And for remaining angles, it is helical, right? Let us now continue. Right. So we have discussed that path is helical. Now, if you consider both the fields, means electric field and magnetic field, then force is given by, you can see because of electric field, force is Q into E bar, and because of magnetic field, force is Q into V bar cross B bar. That means now we have to consider sum of these two vectors. Okay. Or I can take it as taking Q outside. So E bar plus V bar cross B bar. Okay. So this is now force acting on the charged particle. And here we can have many possibilities like this vector, that means E bar plus V bar cross V bar. This total vector can become zero. That means when electric field and magnetic field, both the vectors are present, still net force on the particle can be zero. Let us see. If F bar is zero, okay, then E bar plus V bar cross B bar equal to 0 bar. Okay, that means E bar is equal to minus of V bar cross V bar. So we can see between these two vectors, it can be any angle, right? Except 0 and 180. Because here we are taking E bar and B bar are non-zeros. Okay, that means angle can be any value other than 0 and 180. Okay, this is one condition where net force equal to 0 even though both the fields are present, right? And we can have many questions basing on this. Let us see now problems to get more clarity. Right, see the first problem. This is asked for 2 marks in 1985. A proton moving with a constant velocity passes through a region of space without any change in its velocity. Its meaning is velocity not changing. That means acceleration is zero. Acceleration zero means net force is zero. Okay, right. If E and B represent the electric and magnetic field respectively, then this region of space may have. Okay, so condition is that net force must be equal to zero. Why net force means? Because velocity is not changing, right? Then one possibility, both fields are absent. E0, B0. This is one possibility. No electric field, no magnetic field. And here one more thing, we are not taking gravitational field. Okay, only these two. Next. See second possibility. Electric field not present, but magnetic field is present. See, this is also possible, relation is if velocity is along b bar, if velocity vector is parallel to magnetic field vector. If you remember, first case we have discussed angle 0 or 180. 0 means along B bar, 180 means opposite to B bar. Okay. Then force will be 0. That means even though magnetic field is present, magnetic force is 0. Okay. That means this is also possible. Next, no magnetic field, but electric field is present. Once electric field is present, force will be there. That is a Q into E bar. Okay. So if electric field is present, electric present means electric force is there. That means net force cannot be zero. Therefore, this is not possible. And see last option, both vectors are non-zero. Means both fields are present. So just now we have discussed, right? E bar plus V bar cross V bar equal to 0 bar. This is possible. Means except C, remaining three options are possible. Okay. So like this, we can expect some simple theory questions, okay, basing on the concept. Let us see next problem. Consider the motion of a positive point charge in a region where there are simultaneous uniform electric and magnetic fields. We can say electric field along y-axis, positive y-axis, magnetic field also along positive y-axis. So both the fields are in the same direction, that is j cap, and charge is positive. At time t equal to 0, this charge has velocity v in xy plane, making an angle theta with the x-axis. Which of the following options are correct for time t greater than 0? Right. So it is given both fields are present and both are along y-axis. At t0, it has velocity v in xy plane, making angle theta with x-axis. Let us see options. Angle 0, circular path in xz plane. 0, charge undergoes helical motion. It is helical path with a constant pitch along y-axis. 10-degree helical path with its pitch increasing with the time along y-axis. Okay, let us see how to decide these options. Both fields along positive y-axis and velocity is making angle theta with x-axis. Right now, see carefully. First of all, force acting on charged particle F bar Q into E bar plus V bar cross B bar. Okay. And given both the fields are along positive y-axis, E naught J cap, B bar also, it is J cap. Suppose this is x-axis and this is y-axis. Velocity vector is making angle theta with x-axis. Okay. If theta is not equal to 0, if theta is not equal to 0, then see the possibilities. Condition 1. For example, focus only magnetic field. Okay. If you take only magnetic field, when theta not equal to 0, 90 and 180. Path is helical, right? Theta not equal to 0, not equal to 90, not equal to 180, then path is helical. And observe carefully, coming to pitch. How pitch is calculated? It is V parallel into time period of revolution. This is only when magnetic field is present. Okay. But here, electric field is also present. Okay. So see the possibilities now. Take first possibility, theta equal to 0. Theta 0 means it is along x-axis. Get the point. But both fields along y-axis. That means because of magnetic field, it is only circular path. Okay, because of only magnetic field. And because of electric field, always force acting along positive y-axis. Okay, suppose I am taking theta equal to 90. Theta 90 means velocity vector is along positive y-axis. It is along positive y-axis. In that case, both velocities means velocity along positive y-axis means because of magnetic field, no force acts. Because of electric field, force is along y-axis. Then path will be straight line. It is straight line. Okay. Next. See the next possibility. So option 1, if you observe, theta 0, charge moves in a circular path. That is not possible because theta 0, if only magnetic field is present, it is circular path. Okay, that's why option 1 is not correct. Okay, next. Now we have cross-checked that theta equal to 90. It is straight line. So option D, theta is 90. The charge undergoes linear, means straight line, but accelerated motion along the y-axis. Since electric field is present along y-axis, electric force also along y-axis. That means along y-axis, there is an acceleration. Therefore, option D is correct one. Okay. Option D is correct. Next, coming to option B, theta 0. Charge undergoes helical motion. That is not correct. Okay. Next, we have to focus theta equal to 10. Theta is 10. Charge undergoes helical motion with its pitch increasing with the time along y-axis. So see this point carefully. Option C. Option C. While calculating pitch, we have to focus V parallel into T plus half A T square. So when we are taking only magnetic field, it is only magnetic field. There is no acceleration along the magnetic field direction. That's why here we have taken only V parallel into T. Okay. But coming to here, along magnetic field vector, we are having electric field vector. That means because of this, we have taken now half A T square. This is now pitch. That means with the time, pitch is now increasing. The reason is that this V parallel is not a constant. Here important point is V parallel is not a constant. Even though this is a constant, half A T square is a constant and T is also constant. But coming to V parallel, it is not a constant. That's why pitches keep on increasing. Okay. So in this case, what we are saying, pitches keep on increasing because of the presence of electric field vector along the magnetic field vector. Therefore, option D is correct one. Okay. Therefore, correct options are, it is C, right? When theta equal to 10, it is a helical with pitch increasing. Why increasing means because of the electric field. Okay. Option C is correct. Option D also correct. Okay. Let us see next one. An ionized gas contains both positive and negative ions. Given ionized gas contains both positive and negative ions. If it is subjected simultaneously to an electric field along the positive x direction and magnetic field along positive z direction, then asked for 2 marks in 2000. See options. Positive ions deflect towards positive y direction and negative ions towards negative y direction. Okay, we have to decide right, in which direction they deflect. See one directions. Ionized gas contains positive and negative ions. Electric field along positive x-axis. Right, electric field and magnetic field along positive z direction. Let us see how to solve this. So if you consider initially the ions were at rest. First of all, electric field. Electric field is, see it is in which direction? Along positive x axis. Let us take E naught I cap. B bar. B bar. It is a B naught direction positive Z. That is a K cap. Right. Now see what we can do here. If we assume initially the ions were at rest, because of magnetic field, no force acts on them, right? Because magnetic force is F bar equal to Q into magnetic force. Q into V bar cross B bar. Okay. So since initially they were at rest, no magnetic force acts on them. Now force acts only because of electric field. So because of electric field on positive ions, force will be along positive x-axis. That means I can take velocity vector. It is along positive x-axis because of this electric field. I am repeating. Initially, ions were at rest. If you take positive ions, because of electric field, force will be along positive x-axis. So velocity is along positive x-axis. And when these are having velocity, because of magnetic field force acts, then see carefully. If I am taking positive charge, it is a plus. B. Direction is I cap. Direction of B bar, it is a K cap. So I cap across K cap. I cap across K cap, it is minus J cap. That means on positive ions, direction of magnetic force is along negative y-axis. Okay. Now, what about the negative ions? Then see carefully. For negative ions, velocity will be opposite to direction of electric force, means negative x-axis. Then see what happens. Force. Force because of magnetic field. In charge is now negative. So take negative there. Velocity minus I cap direction part. Field K cap. Minus minus becomes a plus. Remaining is minus J cap. Means on negative ions also, because of magnetic field, force will be towards negative y-axis. That means on both ions, force acting in the same direction. Means both ions will deflect along negative y-axis. Okay. Now see options. All ions deflect towards negative y direction. It is option C. Okay. Let us see next problem. A particle having mass m and a charge q is released from rest from the origin, in which electric and magnetic field are given by E bar equal to E naught k cap and B bar equal to minus B naught j cap. Find the speed of the particle as a function of z coordinate. Okay. Initially it was at rest, released from origin. E naught k cap, B naught j cap minus, right? See how to solve it. And this question is taken from H.C. Verma. Initially, velocity was 0. At origin, V is 0. It was at origin. Electric field is present. It is E naught k cap. Magnetic field B bar minus B naught j cap. Okay. So we have to find velocity as a function of z coordinate. As a function of z coordinate. See how to start the problem. So first we are focusing. Initially velocity was 0. Finally we have to find what is speed, right? That means we have to focus now what is the change in kinetic energy. And we are knowing that from work energy theorem, net work equal to delta Q, right? Net work means work done by magnetic force plus work done by electric force. Net is now delta K. Delta K is now final value half mv square minus initial value 0. Initial value 0. And we have learned that because of magnetic force, no work is done. Okay. Therefore, this is 0. Remaining is only electric force, right? And because of electric force, you can see electric force is a constant. And we have learned that while calculating work done, if a force is a constant, take directly F bar dot S bar, right? Integration is not required. And in this, we can write it is F into S cos theta. See meaning of this. Multiply the force with component of displacement. This is when force is a constant. I am repeating. Whenever force is a constant, if you want to calculate work done, multiply the magnitude of the force with component of displacement along the force. Now exactly we are doing same thing here. It is 0 plus electric force Q into E. I am taking here modulus value. Multiplying that with a component of displacement. along z axis. Initially, it was at origin. So z coordinate was 0. After some time, it is z. Then displacement along z axis, it is z minus 0. Are you getting it? Since electric field is along z axis, we are focusing displacement component along z axis, right? F into S cos theta, that is equal to half m v square, right? Remain just calculation, v equal to 2q e z upon m under root. So just applying the key point that magnetic force is doing no work. Okay.